All right, I believe we are live. So welcome everyone. We will hang out a little bit until we'll let the people stream in here.
All
Make
right.
sure everything's working.
Hello to those joining.
You've got Ben and you've got Chris, or as his name tag says, Muns today. Let's look over here. Yeah, live looks like it's working. Great. Okay. How's it going, everybody? So we've got Postgres generally available today. Very exciting. This live stream is basically just so that we can answer customer questions, demo some things, show you guys around. So you've got me today. You've seen me on the streams before. I'm Ben. And then we've got Chris Munns here as well. We're going to chat a little bit. Munns is going to look at the customer questions or audience questions as we go and see if there's some interesting stuff that we can cover and go over. And yeah, but we'll wait to dive in just for a minute so people can come in here.
Nice. Hey, Brian, thanks for joining us.
Hey, Brian, good to see you. Got Brian. And we're streaming this. A lot of you are probably coming in from X, but we're streaming on YouTube right now and also on LinkedIn. So wherever you're coming from, you can drop comments below the video if you have anything you want to talk about, ask about. So yeah, Postgres being GA means we've been in early access for a long time, since earlier in the summer. So there's a number of you that may already have Postgres databases on PlanetScale. But as of today, anyone can create an account, sign up. You don't need to get approved, generally available and ready to go for whoever wants to start using Postgres on PlanetScale. So let's look here. All right. Well, I think I'm going to bring up our screen share. Chris, do you want to say anything before we go?
No, I mean, I think, folks have joined us in the past. We're excited here today to announce that PlanetScale has made PlanetScale for Postgres GA. There's been a lot of exciting work over the last couple of months since we first announced the preview on July 1st. And so we're really excited to see how people start kicking the tires on it.
Yeah. And yeah, our engineers, we're the faces of this live stream, but it's really all credit to the incredible engineering staff at PlanetScale. We have some incredible people here. Let's see. Oh, there's a few more comments. I'll just put them up. Nice. Going to give it a try today. Great.
Nice.
Very exciting. Yes, we agree. It's very exciting. All right. So let's talk a little bit about just what you can expect. We probably have some people on this call, on this live stream, that are existing users. You've used PlanetScale, you love it, you're kind of familiar with it. But we probably will have a bunch of new people signing up today for the first time. So the first thing I want to show is just after you create your account, you go to planetscale.com, sign up, you'll create a user. And then also it's a similar structure to kind of what you have on things like GitHub, right? Where you can have organizations, and then you can create repos in an organization, you have organizations and you can create databases within those organizations. So I have an organization here, SpeedyDB, and I'm going to click create a new database. And one thing I'll note too is there's an import database thing over here. This is actually for Vitess and MySQL databases. So we have a bunch of docs, and Munns wrote a lot of these, so maybe he can talk about that a little bit later too. A bunch of great docs for importing databases. But just for getting up and running, you're just going to create a new database. And so you give it a name. So choosing your region, this is important, right? Because you always want to make sure that your database is as close to your other infrastructure, your app servers and all that as possible. So make sure you pay attention to what region you're selecting here. I'll just click US West 2. And then let's see, maybe I'll zoom in a little bit here. Kind of the big decision, we're talking about Postgres today. So we're going to stick with Postgres databases. But like I mentioned before, we also do Vitess, which is powered by MySQL. So we have a lot of customers on this, and this does database sharding and a number of other things for really high scalability and high performance. But we're going to create a Postgres database today. And then this is one of the things that sort of makes PlanetScale stand out from a lot of others, is that we give you a lot more options for where your data is stored and how it's stored. So we do network attached storage in AWS. That means EBS. In Google Cloud, that means persistent disk. And that's great for storage flexibility, right? Because we have auto scaling. We can auto scale your disks since the storage and the compute is separated. So there's a lot of advantages to that, but that can lead to a little bit higher latency IO, and sometimes that can lead to IO bottlenecks. So if you have like really high IO demand workloads, we generally recommend and steer customers towards using Metal, which is still in the cloud. It's still in AWS and GCP, but you're using locally attached NVMe drives for these. So you get really low latency IO, no IOPS limitations. You're generally never bottlenecked on IO when you're using Metal. So we've got lots of different sizes for this. I'm going to create a smaller one just to kind of show you the process of creating, but I have some databases already spun up that we can use to kind of demo some of the features and stuff. So let's see. We've got, we're going to create like just a PS10 here. And then the other choice too, and this matters for both of these, especially when you're on Metal, but you actually get to choose what architecture you're on. And this is an important choice because it's easy to resize your database within the same architecture. So if you decide on Intel, it's easy to do resizes between any of these, or even over in Metal world, any of the Intel-based Metal instances. But we don't have direct ability to switch between architectures because there's some differences with even just like data storage between those two. So pick your architecture, pick your database type. So we'll go over here, and then we're going to hit create. Let's see. Yeah, I saw in the chat a comment from me, and I was like, how did that happen?
Yeah, sorry.
Oh,
yeah, me too. Yeah, we talk about selecting a region. Sometimes you might have your infrastructure not hosted with one of the cloud providers. You might be using a third party, or be running in a different hosting provider. And so in our CLI tool, you can use the ping command to actually see the network latency to each of the regions that we support our products in. And so sometimes, the internet is a complex place, and as the bird flies may not be as the packet flies. So the ping command helps you see that list of what the latency looks like to those regions. So definitely a good way to help you in selecting one if you're not in, say, AWS or GCP today. We got a great question here. What's GA? So GA just means generally available. So PlanetScale for Postgres now is available to anyone who comes and signs up and creates an account and logs in. Previously, it was just a private preview, and so you had to get kind of allowed into the product on our side. But today, there's nothing blocking it, so you can go and sign up and start using it right away.
Yeah, and Kenway says globally available. That's not what it means, but that's also true. It is globally available.
Yeah, we are both globally available and generally available. We are generally globally available.
Yes, exactly. All right, so yeah, this earlier you saw I created this database. Usually you can expect it to take a couple minutes because every time you create a database, we're spinning up the infrastructure across multiple availability zones for this database. So this might take a few more minutes, but I planned for this. So we have another database already ready to go. And got a couple of fun things we can look at here. I'll start on the dashboard.
Yep.
And again, if you are an existing PlanetScale user, you probably look at home here. This looks very familiar. But if you're new to it, there's a lot of useful stuff that sort of, hopefully you don't miss in this dashboard. So a couple things we'll talk about is, first of all, our default architecture. Like you have this architecture diagram right off the bat. And by default, I clicked on it, so it took me to the metrics. But by default, all of our production databases, you actually get 3 database nodes, which maybe is a little bit different if you're coming from another provider. Often you just start with 1 node. But what we do this for a number of reasons, but one of the biggest reasons is high availability, meaning that occasionally it's the cloud, right? Servers can fail, there can be network issues. And so if there's ever an issue with a primary server, we have the ability to automatically switch over to use a different server. It's called a failover. So this makes your database be really highly available, even in the face of server issues and things like that. Stuff that's outside of any provider's control, just AWS or GCP. So you get these nodes. You can also send some of your queries to your replicas for additional capacity. It's also good for data durability, having that replication. And let's see. Yeah, so that's kind of the idea here and like what you see. And then you get an overview of how many connections to different nodes and the resource usage. And also this table over here provides just a really nice high level of, in this case, it's a metal database. The other one I created was network attached storage, but this one is an M320. And so this is really high performance IO. I've got local NVMe drives on each of these servers, and each of them is like 930 gigabytes, and I'm using 530 gigs, so it's 60% used. And you can see like I've got lots of IOPS, so not IO constrained here. We give you metrics for your, egress only here, but you can look at ingress as well. So a great high level overview, right? This is where you're going to start when you look at your database, and you can see just kind of the health of your database and what's the structure of it. And so let's see, there was a question about using a metal branch for initialization. Oh yeah. And Chris linked to the docs. Great. Yeah. So sometimes metal branches, you will notice, will take a little bit longer. But either way, it'll take a few minutes just because there's infrastructure to spin up. When you
I think the comment was more like, why are you not using metal in this case?
Oh, why am I not? Well, that's what I have just switched to.
Yeah. And so for what it's worth, I think spin up time is actually pretty close. Typically only takes maybe 2 to 3 minutes at most for the cluster, I think, in the past that I've seen to spin up. So it's fairly quick to get a new branch up and initialized. And that's typically not dependent on storage in that case.
Yeah. And I'll address this other question too. There's a question about free plan, and we don't have a free plan. However, what I will say for people that maybe just want to try this out is your bill is prorated. So if you create a database and it says it's $35 a month, if you only create that and use it for a couple of days and then destroy it, it's not going to charge you the full $35. It's prorated based on how much you use that in the month. So if you just wanted to try it for a couple of days, sort of see if you like it, if it fits your needs, you don't have to use it for a whole month, and you can sort of have a small, not be charged for that full months of use, basically. Okay. So let's look. This is a test database, and it's one that I was using for benchmarking a couple of days ago. And so it's got a bunch of data in it already. And I've also been running queries on this. We can see like it's using a good amount of CPU right now. So I'm going to go over and just show a couple of start by like looking at the observability side. Like once you have this database, how do you see your resource usage and what queries are running, and how do you identify if things are going slow, all of that kind of stuff. So this is our metrics page, and it was running a bunch of queries all night, but then this morning I started throwing more load at it. So let's just look at the past like 3 hours, or even actually we'll just zoom in so you can select particular ranges. So I'm going to zoom into this range here, and we can see stuff you'd probably expect from a lot of providers, right? Things like what's your CPU and what's your memory usage? What is your current IOPS usage, storage usage, these kind of things. I'll show you in a little bit how this can be really useful to go and correlate with stuff in our insights view, because that's a great way to sort of figure out when certain queries were running, did that cause resource usage issues? But then as we go down, there's some additional things here like, so there's a number of graphs for PG Bouncer, which maybe we'll talk about later, but that's a connection pooler that we provide by default. So you can make direct connections to Postgres, or often we recommend using PG Bouncer, especially if you have infrastructure where you need to make a lot of connections, hundreds or thousands of connections to a single node. You always want to go through PG Bouncer for that due to Postgres's architecture. But for these benchmarks, I've just been doing direct connections. But we can see some more detailed things too, like it's not particularly interesting looking right now, but a breakdown of not just how much memory am I using, but how much of this is active cache, how much is inactive, OS page cache, a breakdown of connections over time and what kinds of connections those are, and even information about your ingress and egress into and out of this database. So this is where you go, right, to just see those general metrics, look at the health of your cluster. And this is generally probably where you're going to be looking if you're thinking I'm oversized, so I need to, downsize my database, or vice versa. Things are going well, things are growing. I think I need to increase my node size. You'd be looking and monitoring these resources to see, where am I constrained? Am I constrained on CPU? Am I constrained on IO? Things like that. Let's go back up here. So this is interesting, but then probably my favorite feature of Postgres and really just PlanetScale in general is insights, at least in our UI. So let's look over here, and there's a couple of places and graphs that I want to show you, but we'll start by just changing this view to the past hour. And the first graph, let me zoom out so we can fit this all a little better. So the first thing that you're presented with is your latency graph, right? So we can enable and disable your P99, your P50, even your max query latency. And this is generally where you're going to go if you're having issues with query performance, if queries are loading slowly, you're having latency issues with your application, but you think it's correlated with your database. This is where you would come to look. And we can see, like, right off the bat here, for example, I have this little period of 10 minutes where latency got a lot higher, right? And even especially when I go to P99 or even max latency. And so this is something where I'm already zoomed in pretty close to an hour. But normally, if you're like zoomed out and you see, okay, here's like this spike, I can just zoom into the exact time window that I want to look at. This graph loads, but then that also updates down below. So all of these queries it's listing here are the queries that were running in that time frame. So now I can start to narrow down like what was running slow during that time.
Mm-hmm.
Yeah,
we've had a lot of fun working with customers over the last couple of weeks who have, begun their migrations over to PlanetScale for Postgres. And when we get into insights and they start seeing some data, then there's kind of that like, whoa, what's that thing? Wait a second, what's that thing? Wait a second, what's that? And for the team here, helping customers review this has been really enlightening because, over time there's, query cruft effectively in how you build your application and how complexity kind of creeps in from time to time. And you don't typically get this kind of visibility. And so once you do have it, then all of a sudden it becomes this thing that is, as you were saying, Ben, like even more interesting than just metrics. Like most people are used to just looking at metrics.
Yeah.
But insights really gives you that extra leg up to be able to get this much deeper visibility into what's happening.
Yeah, exactly. And I think especially in the Postgres world, unless you're using something like PG Analyze, which gives you a lot of good info, but that's an extra cost, right?
Mm-hmm.
Most people aren't used to this level of observability into the queries that are running on their database.
Yeah. And so everything we're showing here is just included with your database cluster. There's not something that you're paying extra for this. It's just right there.
Yeah. So yeah, this
couple questions that have crept in here. So there is one question here from Kenway. Any plans to have serverless in the future? I assume this maybe means like scaling to zero, or actually, Kenway, if you want to clarify more about what you're asking there. But today with our network attached storage, that will actually both increase and decrease on demand. Serverless with databases is kind of a mixed bag. In the many systems, you do have kind of cold start or spin up penalties. And generally, you can run into all sorts of issues when trying to shrink the amount of CPU and memory that a database has. And so today, when you provision a cluster, that CPU and memory is basically firmly set until you go and change that cluster over time.
Yeah. Good point. Yeah, and there was also a question about let's see, branch merges on PGUN. Okay, so what you might be talking about here is the way branching works on Postgres, a little bit different than if you've used our Vitesse product. So in Vitesse, we have not only branching, but branching with schema, and then the ability to do deploys back into main, kind of like you're used to working with on Git. So we don't have deploy requests on PlanetScale or schema-based branching yet. One of the nice things about Postgres is it does have a little bit of a better default story around schema creation and management. A lot of that is because schema creation works fully transactionally. So you can create multiple tables all within one transaction and they'll either succeed or fail, things like that. So the default story is better, but you are right. We don't have the deploy requests yet for Postgres. Yeah. And I don't have a timeline for you, unfortunately. But let's jump back into insights a little bit here. A few other things I want to show. So like we were looking in here at, okay, there was this segment of time where queries looked like they were getting slower. And you can come down to look at your queries. There's a bunch of different columns you can add and remove. So I could say like, I want to see what % of the time is this query running. I can remove things if I want. But a good thing to look at, especially when you're trying to figure out what queries are running the slowest. I often like to sort by rows read over row returned. And you usually don't want this number to be high because that means a query was reading lots of rows, maybe a big table scan or something, but then it was returning only a very small number of those, which means it's probably doing something wasteful, or you probably need to apply an index, something like that. And here it's not too bad. I don't have any egregiously bad full table scans or anything. But once you've identified what queries you think are causing problems, you can click on it and get a specific query view for the latency of this. And you can see which indexes it is or isn't using. In this case, it's always using these two indexes 100% of the time, which is a good sign. But this is a really nice way to drill in. It'll be very obvious if you have some, full table scan or some query that's just doing something not very smart. It'll be very obvious once you come into insights, and then you can take actions to mitigate those. This database does not have any right now. Again, the performance is actually pretty decent on this, but we also have schema recommendations. So when you come in here, a lot of people will come in and start moving their load over. You'll probably see this turn green, and it'll say that there's some recommendations. And we actually automatically do things like recommending you adding indexes, recommending unused indexes. I forget the full list right now. I think we recommend if rebuilding indexes, if there's schema bloat. Yeah. Are there others I'm missing, Chris, there?
Yeah, so we've got removing redundant indexes, preventing primary key ID exhaustion, dropping unused tables, dropping unused indexes, rebuilding bloated tables, and then rebuilding bloated indexes. And I know the team is actively working on a bunch more, so definitely keep an eye on this place. And the docs link that I dropped here, folks, is the most accurate kind of list of what's here today. And again, as Ben was saying, your database may not be experiencing these, so you won't see those recommendations. But it's been pretty cool to see this, show up for some customers, and then all of a sudden they've got these fixes that can be really impactful to your database performance.
Yeah. So if you don't see it, don't feel bad. That's actually a good thing.
It's a good thing. Yeah.
Your database well.
And if you do see it, don't feel bad either. Just know that you can correct the issue, and then things will be fine.
Exactly. Cool. So let's go look at, I actually have, a few days ago, I think it was the 19th. This graph is just kind of fun. I tweeted about this the other day, but I was doing a bunch of benchmarking of testing some IO tunings that we were working on.
Oh, that is fun.
And so this isn't what hopefully your production load doesn't look like this. If it does, maybe come talk to us. But this is showing a bunch of different benchmark runs. And the thing I wanted to point out here too is you can see all these little gears. And what we do in Insights is whenever you do a parameter change, which I'll just click on one of these so we can go look at that view real quick. But if I'm like, hey, I see in my Insights at this time slot, I changed a config, it brings me over to my changes log. And it shows me I changed my effective IO concurrency and my maintenance IO concurrency, and I increased those values. And so this is a great way to you can change a tuning on your database and see if that improved or made performance worse. And this is kind of a great feedback cycle, so you can keep improving performance and all of that. So I've got that whole change log here. And while we're here, I'll just show this tab. The parameters tab is where you would make those changes. So we give you options to control a bunch of the stuff that you would set in your PG comp file if you were managing this yourself, but you can go in here and tune all of that.
Yeah, and you can just type in a search there too. You don't have to.
Oh, that's right.
Quite a list. I think there's 40 or 50 at this point that we expose. And so the other thing that we'll highlight here, and maybe we'll talk a little bit more about this soon, is we are exposing just regular real Postgres to you. And some of these things actually do require process restarts. And so we'll talk about how we orchestrate those to try to minimize downtime for you, and some of the controls in there as well. But it's quite a lot of flexibility that's exposed through this for you.
Yeah, I do want to talk about that. We'll finish Insights, and then maybe we'll come over here since we're on the subject. So let's see. We talked about config changes, and then we'll quickly just look over at. I don't actually think I have any anomalies on this database. Maybe I should have done some worse things to this database, but we'll also automatically detect when you have too many slow queries. Basically, we keep track of sort of what is your average execution time for your queries, and if we see those start to jump unexpectedly, then we'll actually warn you of that, and we'll specifically identify these are the queries we think are causing that slowdown, and so you can investigate those. But my database is pretty healthy right now, and you can look at QPS, your rows read and rows written. And then finally, this can be a very useful view if you're trying to figure out errors, right? If your clients are disconnecting or erroring, you can come in here and see, select a time range, look at all the errors that are happening, and it tells you which ones, how frequently they're occurring. So basically, the summary is Insights is kind of, if you have any either issues with queries due to performance, due to just failing, erroring out, this is the place to go to drill in and identify and fix those problems. Anything else on Insights, Chris?
No, again, I think it's always interesting to see kind of what bubbles up and how you can look at these. And to your point around showing the rows returned and stuff, again, you can also show like the P50 and P95 metrics for in terms of how those queries are performing. And, query performance directly relates to needs for scaling your cluster or for understanding, what data you have in your database. And so, going through kind of all the different data that's exposed and looking for where, things might be performing the worst for you can really help with, again, your end customer experience, as well as helping you with, scaling or being able to scale further over time.
Yeah, agree. All right.
Let's do cluster configuration. We got a question here about how do you scale an existing cluster? So maybe we should show, let's
go through cluster configuration. This includes where we do parameter stuff too. So we'll look here. Yeah. So to address that particular question, how do you scale a cluster? That is down here. So we're currently on an M320, and we'll just expand this. So if you wanted to scale, you'd open this up. And a couple of things I'll point out is, so these instances here are non-metal, and I could pick any one of these sizes, right? And the part of the reason is these have auto scaling storage. So I could pick a really small instance type, but it will, when it does this resize, it'll allocate the appropriate amount of storage for that. But then if I go down to metal, there's certain ones it won't let me pick because it knows, like, I can't scale to an M160. I might need to zoom in a little bit here, but I can't scale to this because it doesn't have enough attached storage, but I could scale up to something that has a disk large enough to fit my data. So you would click this. I'll just like stage a change. I won't actually apply it. You would select what you want. You could add more replicas, but we default to 2, and you queue that. And this isn't going to apply it yet. And so then you would have to, once you're ready, you would hit apply. And this process is going to take some time, usually going from metal to metal or metal to a non-metal database takes longer because there's more data copying from one disk to another. So in the case of a 500 gig database, there's a lot of it depends here, but that could take like an hour to actually complete that. But if you're going from network attached to network attached, that's usually a faster process.
Yeah.
And the thing to note here too is when you do this resize, it's a little different than with Vitesse because of Vitesse's architecture. So this does cause a brief period of database unavailability, where if you have connections to the database, direct connections, those get severed. So you want to make sure you have retry logic. So while we're on that subject, I'll go down to looking at maintenance. So there are maintenance windows that you can set. And this is not actually for database resizes, but we also do behind the scenes approximately weekly upgrades to keep your Postgres minor versions up to date and things like that. So if you have particular times that you only want those upgrades to happen at, this is where you'd want to go and configure that. In off hours or lower traffic hours is what people would often pick for this. But let me go back to cluster config. So I've got this little yellow thing here indicating that I've staged this change but didn't apply it. So I'm just going to cancel because I want to keep things as is for now.
Yeah. And I posted a link in here to an awesome bit of documentation that Ben wrote last week about our operations philosophy, how we actually handle these rollouts, how we walk through the process of how things happen when you click these changes and you apply them. And again, you can opt to have those applied during a maintenance window or right away. And again, really what we try to highlight here is, again, we try to make this be as seamless of an experience as possible. Customers talk to us about how important it is for it to not involve a lot of downtime for them, for it not to become a thing that they have to worry about. And so there's a bunch of great detail on that post that really talks about all of the complexity that we mask behind the scenes for you so that you don't have to worry about it yourself.
Yeah. Yeah, it's a good read. Yeah, it goes through, like Chris said, our operations philosophy. So definitely check that out. So that's resizing. We'll look at storage is actually not a very interesting tab when you're on metal. Let me get rid of this comment here. Because when you're on metal, it's a fixed size disk and it's very good performance, but there's not much to configure because it's a fixed thing. So I'll actually go to, so that database I created at the beginning, that's ready now. So just to show you what it looks like for an EBS or a network attached disk, this is what that storage tab looks like. So the default size that I'm getting is 10 gigabytes here for my minimum disk size, but we have an autoscaler that will autoscale your disk up and even autoscale it down if you have it enabled. So I could say I never want my disk to go below 100 gigabytes, right? So that would be your floor for the autoscaling. And then you can change it where you only autoscale up, or you can autoscale both up and down, or you can turn autoscaling off entirely and configure what the maximum size for that is. So a lot of options just for controlling that up and down scaling. And then also on AWS, this particular database is backed by a GP3 EBS volume. And we give you default values for IOPS and throughput, but if you need higher performance on those disks, you can scale up your IOPS, scale up your bandwidth, and it updates, how much that's going to cost as you configure those things in here. So then, a good thing you might do here is if you were on this database and if you went into your metrics, I can recall this happening with a customer. If you were on 3,000 IOPS, so that's IO operations per second, and then if you came in and looked at your IOPS graph and you noticed that it was kind of like stuck at 2,500 or 3,000, that probably indicates that you're bottlenecked on your IO, right? Maybe your CPU has more capacity, but it's just you don't have enough capacity for going to disk. And so that's when you'd know to go upgrade that configuration option over here. So that's the storage. We'll go back to our other database. Where was that at? Cluster config. And then parameters we looked at before, but again, this is just vanilla Postgres under the hood with all of the powerful operations of PlanetScale and usability and features. But like the way you configure it is ultimately the same way you just configure Postgres. But instead of editing your postgres.conf file, you can do it through our UI. So you can scroll through and there's a bunch of parameters we let you configure. We had mentioned earlier that there are some that require restarts. And as I scroll through, you can see these are called out in orange here. And the reason why that's important is because this is a Postgres requirement. Some configuration changes just require that the Postgres process be turned off and turned back on and reloaded in order for these to take effect. So if I were to change the size of my shared buffers, I again would queue this parameter change. So it's not going to apply it right away. And then I would go up to the top, and when I'm ready, hit apply. But it's going to warn that because of this restart, connections will get severed, will get terminated, and it depends too if you're not using PG Bouncer. So PG Bouncer is that connection pooler we talked about, which was one of the reasons why we recommend it, because connections will stay if you're using that. But if you're going direct to Postgres, because we have to turn it off and turn it back on, those will get closed. So if you're comfortable, you apply those changes, it does the restart, and then you're back up and running.
Yeah, and that's not to say that you wouldn't necessarily want to apply changes like this from time to time. If you're seeing an incident where your database isn't performing well and you've determined that some of these parameters need to be tuned for your workload. Again, for most language frameworks and most clients of Postgres databases, they will attempt to reconnect pretty quickly. And so again, this isn't the type of thing where you should see a large downtime type of an incident.
Yeah. Oh, and someone asked, is alerting supported for metrics? So we don't have built-in, in our app, alerting for this. There's a few things. For example, if you're on Metal, we will send email notifications if your disk is getting too full. I forget actually if we do that on network attached as well or not. But if you want full-featured alerting, what we recommend is we do have a metrics exporter. So you can pull a bunch of metrics out from your PlanetScale database to Prometheus, and you can set it up or link it in with Datadog, Grafana dashboards, all of that. And then you can set up your own custom alerting based on those metrics.
Yep. And that's really what we recommend, because you can get an incredible amount of data with a Prometheus integration. That allows you also, if you have other observability tools that you're using, maybe across other parts of your infrastructure. It should just make it look and feel like any other service that you're managing.
Yeah. So I'm gonna, and pointing out too, a lot of these parameter changes don't require restarts, but you just got to be sort of extra careful when you apply those restart ones. I'm going to cancel those. And then Chris can probably talk more about extensions than I, since you did a lot more with this coming up to launch. But we have support for a number of extensions. So you want to take this one?
Yeah, as you just said, we've got support for a whole number of extensions. I'm going to post the link to the docs in here as well. If you've been developing with Postgres for a while or for any period of time, you probably know that it has an incredibly rich ecosystem of plugins that are both native or community driven. And they really kind of give you the ability to add all sorts of non-native capabilities to Postgres. Some of those are for administrative use cases. Some of them are for data. Some of them are for integrations with other tools. The philosophy that we've taken here at PlanetScale is really that we want to have well-vetted, well-trusted extensions available to you. And so what you'll see here are, at any point in time, the list of kind of approved extensions that we have. And so you can, as you'll see here, you have the ability to go and enable them as needed. Some of these are, they require effectively libraries to be loaded into the Postgres server. And so some of them will mention that you need to have a restart, kind of as Ben was talking about the parameter restarts before. Some of them do require a restart. The others you can just go and use directly inside of Postgres CLI and begin working with them. And so again, we've got a bunch of big, really common ones that we see around PG Crypto, PG Vector, a number of ones that we've heard from the community were just must-haves. And we continue to add more to this. So we've got a whole kind of evaluation of ongoing extensions that we're looking for here. And so if there's an extension that you really need that we don't have, do let us know. And we expect to see this list changing, pretty rapidly as we continue to review those. You do want to be careful about some of these. So we do talk about how some extensions can put, extra demand and load onto your, onto your database. And we've seen with some customers where they're using some of these, they may not be aware of the fact that, the data format that's created or supported by an extension actually can be, fairly memory and CPU intensive. But again, you should see all that data in Insights and be able to pull it apart and get a good understanding of that.
Nice. Yeah, I was just thinking, for example, we have PG Vector, right? Lots of people use that for vector storage, but there's also PG Vector Scale, which is uses better algorithms for larger than RAM indexes. And I don't think we have support for it yet, but I think it's coming out very soon because we've had a lot of requests for it. So we kind of prioritize based on what our customers are saying and what they really need the most. So.
Yeah, I think like Postgres, what you see right here, very common, very heavily used. That's one which, we just kind of heard from tons of folks that they needed. Someone mentioned here foreign data wrappers. Foreign data wrappers is in here as well, I believe. PG cron, ability to basically run cron-based tasks inside of Postgres. And again, if you're new to the Postgres space, you might be thinking like, why would I want to have cron inside of Postgres? And there's actually a bunch of really valid use cases for, again, executing different sorts of data workflows through the database. And we see these being really, really common inside of Postgres.
Nice.
But again, so some of these here, we mentioned that from the app or from dashboard, you have the ability to enable them. And then again, some of them will require a restart. And also from there, some of them we apply the configurations to the entire cluster. And then again, others you can just configure directly through the command line. But if you're looking at migrating to us from another platform, do let us know if there's any that seem to be blocking that. And the engineering team here, again, has been kind of rapidly adding to these. It's actually been kind of an ongoing joke here for Ben and I and Holly about like, oh, we got to update the extensions docs. We got to update the extension docs. We just keep getting more and more.
Yeah. Every other day, there's like a new thing we need to add here.
Okay. Yeah. Good feedback here. Someone's asking for Postgres raster. Was told it could be a couple months away. Yeah. Now that we're announcing, GA today, the team is back to looking at expanding this list. And so, Johannes, hopefully we can give you some positive news soon.
Nice. Yeah, and so this is that part of the UI, but I was just showing the docs over there, which I'll mention too. We have a new fancy doc site, but we'll say more on that
Oh yeah.
later today. There's an announcement coming out. So there's our extensions page, and then we showed this earlier. Oh, this is my smaller database. I want my bigger one. I have a lot more config changes on here. So the last tab is our changes tab, and we can actually see in here too. This is interesting. When I had clicked earlier to queue a change to go down to a PS40, I ended up canceling it. And it says here, right, it's canceled. So it wasn't actually applied. But it's still kind of nice that it shows up in my history. So we can see that here was the point in time where I had been considering downsizing to a PS40. And it even shows, had I done this downsize, we also change configuration options to fit, this would have had less RAM, less CPU, a different kind of disk. So we would have changed configs appropriately, but we didn't obviously apply it. And then here's a bunch of the other ones I did in the past for doing some benchmarking on IO concurrency stuff.
Yep.
So I think that's everything in cluster config I wanted to talk about. I guess we could go to backups. A few other things.
Backups are important.
What's that?
Backups are important.
Backups are important, yes. Hopefully it's a tab you don't need to go to all that often, but when you need it, you really need it. So the backups that we do, the basic story is you can actually see there's
one happening right now. It's good timing.
So convenient.
It's great.
But we do automatic backups every 12 hours, I believe. Yeah. So 11 hours ago was my last one, and we retain them for 2 days by default. And this cost is all included in the cost of, what you see when you create the new database, right? We do a certain amount of backup storage that's included. But we also give you the ability to do different schedules. And that does add some S3 storage cost essentially to your bill. But if you need something longer, like maybe your just business requirements for whatever industry you're in require, a 1 month backup retention or something like that, you can go and create a new schedule and say, I want to run, let's say, once every day. So once every 24 hours, and you can even select what time to start at and keep it for 1 month, right? And you can name that schedule. And now that schedule will run in addition to the default schedule of every 12 hours for 2 days. So a lot of power there based on just what your needs are. And then the other thing we have is the ability to restore from these backups, and not just the backups themselves, but to also do point-in-time recovery using your wall records. So we also maintain your write-ahead log history basically as far back as whatever your oldest backup is. So that's what you can do point-in-time recovery through, right? From the present, or I think we say from a few minutes ago, up until your oldest backup. And that's also a reason why you might want to have an older backup than 2 days retained. If you think you have need to go back, a week ago or a month ago, then you're going to want backups that go all the way back to that time.
Mm-hmm. So we had a great question here, which was, what is the max retention period? So if you go to create a custom backup schedule here, let's see, I think if you go and set it for like years.
Yeah. 10 years.
We can delete it later.
Run every day for 10 years. Hopefully I don't forget to do this one.
Yeah.
Save that schedule.
So again, you will pay for the excess. So by default, every what we call production branch here has double the configured storage available as for backup data. Backups typically compress pretty well. We had some kind of early ancillary research that we did that was showing 50 to maybe 60% compression at times. So you do kind of have to see how that goes when your backups start kicking in. And again, some customers' data compresses really, really well. Sometimes it may be a little bit less. The other factor is the amount of writes and updates to your database generates more wall data, and that also gets backed up. And so, as Ben was alluding to, when you create a custom backup schedule, you retain all of the wall data up to that point. So if you want to go further back in history and say, hey, I want to, I want to create and actually we'll talk about this here too. You can create a new branch from my backup, and you can say, I want to go back to a point in time 13 days ago at 12:45 p.m. Eastern. in 30 seconds. And you could basically go and do that back to that period of time, so long as you have the data. And so all of that is, again, storage. So again, beyond that double cluster storage backup, then there is pricing, again, you could find on the documentation page here about this. And there's definitely valid reasons. Some companies who have legal and compliance reasons to hold on to data longer, you have the ability to configure that here.
Yeah. And yeah, like Chris said, if you were doing a point in time restore, hopefully you don't need to go back 9 years, but that's where you would come in and select, like, this is where, I want to go back to, again, I don't have a big history of backups, but maybe yesterday at 11:49 a.m. and then restore. And what you'll do is when you do the restore, you're going to restore to a new database branch, right? So it's totally separate from your production cluster. You don't want to negatively impact that or change the data in production. So you select, maybe just a small instance, right? Because you might just be going back in time to do some debugging or to extract data that you mistakenly deleted, something like that. And then you'd hit restore. It would do that restore and bring that data back online.
Yeah. And this could be a great way to create new test branches that you're using either to play with, say, schema changes, other sorts of maybe data patterns that you want to test. And again, this will, immediately start restoring back from the most relevant backup that was taken and replaying the wall data. So quite a lot of possibility here through the restoring of backups.
Yeah. So let's look at, I guess one other thing that might be cool to show. I also, maybe we'll jump over to the docs and pricing page at the end, but I'll also show the roles page. So this is, role management, connecting to your database and which users have what level of permissions to, read data, write data, access things, change administrative stuff is important. So when you create a database, there is the ability to create your default role, which is essentially kind of like your admin level user that we don't recommend you connect from your applications, right? This would be something you would use for administrative purposes, but for connections from your app, you would want to create separate roles for those. So I'll just show you what that looks like here. I won't show you the actual hitting enter so you don't see the password to connect to my database, but you can create your new default role if you want to override that, but I already have one. And then when you do a new user defined role, you could name the role just what you'd see in the UI here, and you can select what role privileges this role is going to have. You select it and hit create role, and it'll bring you to a page with your username, password that'll only show you one time. So you store that somewhere safe. And then that's how you would control, if you want to give either an app or a developer or something access, but with limited privileges, you would do that through here.
Yeah, click on one of your roles here. I think the other thing maybe we want to show is some of the connection strings that are here.
Is this showing what you expect, or do I need to go somewhere else?
I was looking for the private connectivity, and actually it may not show up in this organization that we have.
Oh, it might be because it's in benchmarks. Yeah.
So one thing to highlight that you'd also potentially see here. So again, Ben is doing this in one of our kind of like internal demo organizations. We have all sorts of oddball feature flags and things that are turned on sometimes here, but we do support the ability for you to use either AWS Private Link or GCP Service Connect. If you're not familiar with those things, those are ways for you to be able to basically connect directly to a virtual private cloud in one of the cloud providers' infrastructures. It kind of changes up the way that you access things and how you think about it. And so typically you would see the strings there that you would use to effectively set up how you would connect to your database. So
I found it. So I went back to my regular organization,
awesome.
Created a new role. And so I think this is what you're talking about down here, right?
Correct. Yeah. So you see here the private connectivity strings, and we've got all of the instructions inside of your documentation on how to connect to this and what's necessary. But that's there, again, just included as part of the product.
Yeah. So role management, we do have, someone asked about alerting before. This is not alerting at probably the level you were talking about, but we do have the ability, some basic webhooks over in our Vitesse product, we have a lot more different webhook events, and I'm sure we'll be adding more and more events to here, but we have some basic ability to do that right now. But you can look for more updates on that in the future.
Someone asked if you have the ability today to restrict IP address access. We don't have that ability just today. That is, however, a really heavily requested feature. And so that's the latest with that.
Yeah. And let's see. Oh, I see. We've got, I assume this is Alex from Software Huddle. So hi, Alex. Thanks for hopping in.
Thanks for joining.
Let's see. We'll look at logs briefly, and then we'll just go look at the website and docs. So one other thing to look at here, we have a really great observability into logs, which is actually different than what we had with Vitesse. So this is actually even a stronger story than our Vitesse databases. You can filter by what level of logs you want to be looking at. You can look at different time ranges of your logs. There's a bunch of different kind of really powerful features that you have in here to, again, if you're debugging problems, you want to see what's going on, go into your logs and look at that. But yeah, let's see. I think maybe one other thing, I want to go over to the docs, and Chris, if you have other docs you want to look at, let me know. But I was going to just call out for migration. So we've done actually streams over the past month or two, even leading up to GA, talking about just instructions and guidance for how to do migrations. I'm sure we'll do more of those in the coming weeks or months here. But if you want to get migrated, we'll at least kind of tell you where to start. So go over to planetscale.com/docs, click on our Postgres tab. Yeah, it looks like we're linking it in the chat as well.
Yep.
And then there is an import section, and there's a bunch of different ways to do imports. We try to give you lots of options because lots of people have different setups. So we have some generic instructions for doing imports with Amazon DMS or with log streaming or even with dump and restore.
Yep.
And we also have a couple of provider specific guides, which will probably expand more options in the future. But we do this just because each provider, has different settings and ways to configure things. So if you want to follow some particular instructions, you can do that. But the other thing that a lot of people actually really like are our scripts. So we have a GitHub repository, so PlanetScale/migration scripts. And we have a few different options. We have some scripts for migrating into the Vitesse product, some for migrating to Postgres. So if you're doing a direct, you're already on Postgres. And as long as it's greater than version 10, which is when logical replication started being supported, and you want to get onto PlanetScale, we have a whole suite of scripts here to help automate basically a lot of the boring and tedious parts of the migration. So I'd recommend coming here if you want kind of the most automated solution, reading through these, figuring out which scripts you want to run and how you want to run them. And Chris, you've actually done some stuff with CloudFormation too, right? For people particularly coming from Amazon, or does that work kind of for anyone?
Yeah, that's correct. So, I mean, it should work for a number of different providers. It's kind of hard coded for Aurora. And so in this repository, there is, I think if you go back one directory in the migration scripts and go to Postgres-PlanetScale, this is where you'll find a CloudFormation template. It actually stands up AWS DMS or database migration service wrapped by step functions. I don't know if we need to show everybody the CloudFormation in there, but yeah, as Ben was saying, and we want to really try to help make it as seamless and easy as possible to migrate. Every migration is unique, and we've worked with customers that are coming from 9.6 on into 17.5 on different cloud providers, running on everything from just like a self-managed VM to some of the other providers that are out there, again, with all sorts of needs around extensions, all sorts of data sizes. We've seen multiple terabytes, we've seen tens of gigs, and so each of those requires a little bit of love and a little bit of attention. And so you'll continue to see more guidance from us come out, more scripts, more tooling, and we're here to help. And you can definitely contact us through support, through our Discord, and we will jump in and try to give you a good starting direction on this. But some of them have been, really, really kind of beefy migrations that have gone really smooth. And so it's been exciting to see some of those come over nice and fast and easy. But we're definitely here to help.
Yeah, for sure. Yeah, and so lots of options, lots of different ways to do it. So pick what's best for you, and then we'll help when you get stuck.
Yeah. I realized we missed one topic, which was around PG Bouncer. So someone just asked,
oh, yes.
Can you talk about a database proxy you guys use on top of Postgres to access it serverlessly? Well, actually, sorry, this is to access it serverlessly via HTTP requests. That's a different topic, but let's talk about PG Bouncer real quick, because this is actually pretty core, I think, to how we think about things.
Yeah. So by default, and Chris, chime in when you want to add things. So we have two options for connecting to your database. You can connect directly to Postgres, or all of your Postgres connections can go through PG Bouncer as well. It's a very commonly used connection pooler proxy for Postgres. And so we give you that ability right out of the box. And generally, we recommend doing that as much as possible because, one, it's better for if you have a lot of concurrency. Postgres is a process per connection architecture, meaning if you have lots of connections directly to Postgres, it kind of starts to bog down performance and a lot of contention. So you can get better performance at high connection counts with PG Bouncer, and it can help smooth over some of the unavailability issues when you're doing like a reconfiguration. So we talked about earlier, if you need to do one of those config changes that require a restart, connections on PG Bouncer will actually be maintained through that, but direct connections will get terminated and you'll have to reconnect. There are a few things that happen with database configuration that even require PG Bouncer connections to get disconnected if we're like fully rolling your cluster for a resize. But PG Bouncer is just generally the sort of safer way to connect to your database, especially at high concurrencies.
So, most frameworks, most languages have some sort of plugin or package that can help with you, connecting to PG Bouncer. And as Ben was saying, we really consider it a general, good practice recommendation on helping to reduce the load on your primary, especially when it comes to doing lots of writes, or if you have any sort of application tier that auto scales or is using something like AWS Lambda or any of the kind of equivalents in the industry. Pointing your application at PG Bouncer will definitely help you with, performance, connectivity, failovers, all of those types of things.
Mm-hmm. And I'll note too, it'll show you this when you make new connection strings, but the way that you use PG Bouncer is just a different port. So instead of 5432, the default Postgres one, it's 6432, and that will route your connections through the bouncer instead.
Yep. You can also direct read traffic to the replicas. Again, that's a parameter that you put onto the connection strings. And this is one thing that we've also found working with customers on migrating. It's been really interesting is that, again, based on our base architecture, you get that one primary and the two replicas. And those replicas are available for you to point your read traffic at. And so, we've had a couple of customers where they've migrated over, they've actually been able to effectively shrink the size of their cluster in terms of the amount of CPU and memory that they've had, because those read replicas are taking so much weight off of the primary.
Yeah. And this is the docs page talks about PG Bouncer above, and then also connecting to your replicas right here, which is also just changing your user essentially to get to those.
And you can add more replicas as well. That was in the cluster configuration screen that Ben was showing earlier. So you can have as many. I think we limit it in this interface. I think there is a way to get more of them if you ask support nicely. But you do have to note that when you add replicas, it does put a little bit of demand on the primary for consuming those wall logs. So there is probably a good theoretical boundary that you want to watch out for. But yeah, you could add more read replicas, especially if you have a workload that's just very, very skewed to high ratios of reads versus writes. Typically you'll see kind of industry standard of like 1-4, or 1-3, or 1-5 writes to reads. But we've definitely seen customers that have way higher read levels than that.
Yeah. So there we go. Let's see. Any other docs you want to talk about, Chris?
Well, again, actually, maybe we should just talk real quick about docs. What's happened with docs?
What's happening with docs? I'm not sure if I'm supposed to blow the surprise. I mean, it's here. We have a new docs page. So we'll have an announcement coming out soon, but we have a new partnership with Mintlify for our docs. And so we just recently, I think basically on Fridays when we officially did the cutover to these, but because we have expanding our product offering, right? Like for a long time, we were just doing Vitesse. So everything was kind of centered around Vitesse. But now that we have Postgres and Vitesse, we're also working on Niki, so a way to do sharded Postgres. And so that will be sort of an additional component of our docs once that is ready to go. So we wanted to kind of have a platform that allowed us to have sort of more control over the structure of our docs. So if you're using Vitesse for database sharding or you're on MySQL, you can stay in this area of the docs, right? If you're on Postgres, you can be over here. We have generic platform docs, CLI. So it's not just a facelift, but it's actually sort of a different structure. And hopefully it kind of helps customers navigate the different database products that we have better. So we're really excited about this change.
Yep, there's a whole bunch of fun features that Mintlify offers up that hopefully we'll be able to pull into the docs soon. So you might see some cool new things showing up in our docs here going forward. If you don't mind, Ben, click on the CLI reference real quickly here.
Yeah.
So like the CLI tool is one that I find to be really, really beneficial. There's a bunch of great capabilities of the CLI tool. Before I was mentioning the ability to ping around the different regions that exist and find the one that is closest to you. You also have the ability to see things like the instance sizes, the cluster sizes that are available in your region, in other regions as well. You could work on kind of our MCP capability, actually, which is pretty cool. It gives the ability to query data inside of your PlanetScale databases straight from the command line. So a bunch of cool things here in the CLI. Excited to see those docs up here as well. And so definitely take a check at that.
Yeah. And we're coming up on time, but I also just wanted to show as well, I guess we'll just go to PlanetScale. If you're curious about pricing for PlanetScale for Postgres, come over to the pricing page. So it shows up as new here now. So during our early access period, we didn't actually have the pricing public. So now you can come in here, and if you want to look at how the pricing either compares with Vitesse or just compares with where you currently are, come in here and select Postgres and configure your instance size, how much storage you need. We have some advanced options too for egress and backup, and start comparing, right? Obviously you can go just try it out in the UI, but if you want to just experiment with some different pricing options in here, you can just head here and look at essentially a lot of the same options that you'd have in the UI when you create a database, but without committing to create the database.
Awesome.
All right.
Well, thank you everyone for joining us here. We're excited. Is there any last kind of wrap up questions? Anything we can help answer for folks? Again, you can head to planetscale.com today and log in and start playing and building here in Postgres. If you're joining us here, so PlanetScale for Postgres is now generally available. That means that you could go in and build on it. We've got a whole bunch of companies that are running in production today. And have been running for several months now. Even companies like Convex that ported over to us months ago as part of the preview announcement. And so hop in, check it out, let us know if you need help, and we look forward to hearing what people are building.
Sweet. I think you wrapped it up perfectly, and I don't see any other questions. So thanks everybody. But we're always here for you. Come to our Discord channel, file a ticket with support, and we're here to help with anything you got. So take care. Thanks for coming to the stream.
Thanks.